Welcome once again to the Transistor lecture series. Here in this lecture, we are going to explore the common emitter transistor characteristics or transistor characteristics under common emitter mode. So this is the common emitter configuration, and here we know the emitter will be common to the input section and output section. So this is our input section and this is our output section. So this is input section and output section. Now if we see what are the parameters associated with the input and output. So in input section we have input current, so which is IB, then input voltage which is VBE, then we have input resistance in common base mode also we have seen that. So input resistance is RI we are denoting. So these are the input parameters, and at the output section we have similarly output current, so which is IC. So this is IC, then output voltage, so which is the voltage between the terminal collector and emitter, so that is VCE, and we have output resistance, so which we have denoted as R0. So these are the parameters associated with the input section and output section. Now if we try to understand the input characteristics, so input characteristics is the variation of input current IB with respect to the input voltage which is VBE, and keeping the output voltage VCE constant. So that is the objective of finding the input characteristics. So input characteristics, if we plot, we find this kind of graph. So you can easily point out that it is same as that of the diode characteristics. In CB configuration also we have seen the similar kind of characteristic curve, but there is a small difference. Here we can see that variation is little slower compared to the CB mode. In CB mode input characteristics, this graph both are exponentially rising, but that was much faster, much steeper, but here it is less. So from this we can calculate the input resistance Ri. So Ri we can calculate as the change in the input voltage VBE to the change in the input current IB, keeping the output voltage VCE constant. So here you can see that for different output voltage it is varying differently. Higher the output voltage, it is more steeper. So here since it is the slope are little flat compared to the CB mode, so Ri, the input resistance, is little higher compared to the CB mode. So this is one important point that we should always note, and this Ri generally in terms of few hundreds of ohms. So compared to in CB mode, which were only few ohms. Then similarly, if we go for the output characteristics, so output characteristics is what? It is the variation of the output current. So here we have the output current IC, which is in terms of milliampere. Previous case we have IB, which is in terms of microampere. So this is another point we should note. Then IC varying with respect to the output voltage VCE, keeping the input current constant. So input current is IB, which is constant. So that is how we find the output characteristics. So output characteristics variation will be like this. Now this is one interesting point. When IB equal to 0, we are getting some value of IC. However, ideally IC was supposed to be 0 for IB equal to 0, but it is not happening. IC is having some finite value, and that is basically IC is equal to ICEO, which cannot be ignored like ICBO, because ICEO we have found that it is 1 plus beta ICBO. So it is something which cannot be ignored, which is having some finite value, finite magnitude it is having. So now if we analyze the different regions, then we find this is as the saturation region, and we are denoting this as the VCE sat. This is the saturation voltage. So after this, transistor current is going towards saturation. So this is called saturation region. Now this is our active region. So in active region, we know that the emitter base junction JE forward bias and JC reverse bias. So this is the active region. Here transistor works as an amplifier, and this region, when IC is equal to ICEO, this region we are calling cutoff region, because here we are not having any input voltage. So input voltage is 0. Input terminal is disconnected. That we have seen in our previous lecture as well. So these are the regions, three regions of the output characteristics, and in CE mode output characteristic is a very important important concept which we will be using in future for most of the electronic circuits. Now here what we find that application active region, this is the application for the amplification purpose. And when in digital circuits, majority of the digital and logic circuits, in logic circuits, we force the transistor, we bias the transistor in such a way that it will work in saturation region and cutoff region. So transistor as a switch, that means transistor activity will be switching between the saturation region and cutoff region. Whereas when transistor is used as an amplifier, we use it in active region. So in cutoff region, both the junctions are reverse bias. In saturation region, both the junctions are forward bias, and in active region, emitter base junction is forward bias, collector base junction is reverse bias. Now the next important parameter here is the output resistance. So output resistance, from this slope we can find as R naught, that is equal to change in the output voltage VCE with respect to the change in the input current IB, and when input current IC. So this is what we are finding as output characteristics. So it will be output voltage to output current. Okay, so make this correction: output voltage with respect to the output current, keeping the input current constant. Okay, so here we can see the variation of IC is less compared to the variation of VCE. So as a result of that, here also we will get high value of resistance, high output resistance. So that is another characteristics of common emitter mode configuration. So we have discussed all the parameters and graphs associated with the characteristics of transistor under CE configuration. So we end this lecture here. Thank you.